So question E gives you information about this line by telling you what its x-intercept and its y-intercept are. The x-intercept is 18, 0. The y-intercept is 0, 8. So side that worked on part E, what did you do, Laura?
So first I labeled x1, y1, and x2, y2. So x1, y1 was 18, 0, and x2, y2 was 0 and 8.
Okay.
And then I did the slope equation to get the slope. So I did 8 minus 0 over 0 minus 18.
Okay.
And so therefore I got the slope 8 over negative 18. And then the problem said that the y-intercept coordinate was 0 and 8. And so I knew that 0 was on the x-axis, which meant that 8 was on the y-axis, and that was the y-intercept.
Okay.
So then I knew that the solution was y equals 8 over negative 18x plus 8.
All right. So your solution was y equals 8 over negative 18x plus 8. Did anybody have something different for this problem? Let's go, Nick.
I simplified it.
Okay, how?
Well, they're both divisible by 2, like both sides, so what I had was negative 4 over 9.
Yeah, so you can just reduce the fraction that you had for your slope down into negative 4/9. Anything else that people did differently?
Will you be marked down on the test for not simplifying?
It depends on how many points the question is worth. I don't think it's worth like half credit. It might be worth like 1 point if the question were big enough. I'm not super fussy, but do try to reduce your fractions to lowest terms wherever the opportunity exists. This is again an example of a problem where we were very lucky to have the y-intercept already given to you in the problem. So you didn't have to do much work to discover what that y-intercept is. I did want to talk a little bit more about this example from the point of view of thinking about intercepts a little bit more, because there are some problems on your WebAssign homework that are more like this, where instead of being given the intercepts, they ask you for the intercepts. So let's suppose that I had an equation, and I want to know what are the x-intercepts and y-intercept of the following equation. So I'm going to give it to you not in slope-intercept format, but instead in standard form. So negative 6x plus 2y equals 24. So given that equation in standard form, how am I going to go about finding the x-intercept, and how am I going to go about finding the y-intercept? What do you think? What might be a way to approach that? We could take the standard form equation, solve it for y. That turns it into a slope-intercept equation. Once it's in slope-intercept format, we could read the y-intercept directly off of it, right? So that's one way of doing it. The problem with that is that then I don't get the x-intercept out of this process, right? So let me suggest a different way of going about this. Laura just told us that she knew that 8 was the y-intercept of the line that you just got, because why? How did you know that this was the y-intercept?
Because the equation, the problem told us that the y-intercept coordinate was 0, 8. And
Okay.
because a coordinate goes in the order of x and y,
Okay.
and the 0 was on the x-axis.
There we go.
Which meant that the 8 was on the y-axis and was directly on the line.
Yes, very well said. So this is what I wanted to call attention to. We knew that 8 was the y-intercept because the coordinate, the x-coordinate at that point was 0. So whenever we're finding a y-intercept, we know already what one of the coordinates of that point must be. Namely, the x-coordinate has to be 0 at the y-intercept. So this is a flip of logic that's sometimes easy to get backwards. But if I want to find out what the y-intercept of any equation is, I can do it by insisting that x be equal to 0. And we can do that without doing the algebra to solve this for y up front. Instead, we can do that algebra after plugging in a 0 for x. So if I want to find the y-intercept of this equation, what I can do is substitute 0 for x first, and then find what the value of y is. So substituting a 0 in for x in this equation, negative 6x plus 2y equals 24, Negative 6 times 0 then goes away, which is always nice, because it becomes 0. And it gives me an equation 2y equals 24, which how do I solve that for y? How do I get that y by itself? Divide by 2. So to find the y-intercept of any equation at all, it doesn't even have to be an equation for a line, to find the y-intercept, I'll just set x equal to 0. And when I set x equal to 0, that gives me a single variable equation that I can solve for y, which is probably a little bit simpler also than solving the whole equation for y with the x's in place. So that's how I would find the y-intercept. What about the x-intercept? What do we have to do differently if my question is what's the x-intercept? Yes, right. So what makes a point the x-intercept instead of the y-intercept is exactly the opposite thing as what made the y-intercept the y-intercept. The x-intercept in the problem that this side of the room just did was 18, 0, and the reason it was the x-intercept was that its y-coordinate was 0. So that's again the sort of the twisted, seems counterintuitive backwards logic. If I'm looking for the x-intercept, what I should be doing is zeroing out the y and then solving that equation to discover the x. And if I do that for negative 6x plus 2y equals 24, put a 0 in there for y, negative 6x plus 2 times 0 equals 24. 2 times 0, again, is 0, which makes that term go away. And if negative 6x is equal to 24, we find x by dividing, this time by negative 6, to find out that x equals 24 divided by negative 6, otherwise known as negative 4. So my point in this was that we don't have to get super fancy to find the x and y-intercepts of any equation. All we have to do to find the y-intercept is set x equal to 0. To find the x-intercept, we'll set y equal to 0. And that way we can use the equation directly to tell us what the x and y-intercepts of an equation happen to be.